I will do the following now. For the rest of the course, I want to do two things. First, I will give you more results like the ones that you have just seen, that there is really a decision between scoring rules and Condorcet consistent rules to take. And that these are really two different classes of rules with different properties also. And because of that, it has really been I would say the basic question has been, which of these classes offers the better rules? Condorcet consistent rules or the scoring methods? And this is really still the central question within voting theory. Should you concentrate on Condorcet rules, and if yes, why, or on the other ones? Let me give you one fundamental argument. And the fundamental argument has to do with majority. And let me go back to a question that I have posed already yesterday. Namely, suppose that a bare majority, let's say 51%, prefer an extreme right or left position. It doesn't matter, right? But it's 51%. So it is the majority of the population. Is that reason enough to implement that alternative? Or if there is a possibility of compromise, let's say 51% are extreme left, 49 are extreme right, there would be a compromise solution somewhere in the middle. Should we now, in this situation, choose the compromise solution, although the, let's say, extreme left position occupied by 51% of the population is the Condorcet winner? Now, there has been a history, I mean, and actually this is very interesting political philosophy debate between majoritarianism against other methods of deciding. So if you take the majoritarian argument serious, then you must choose the Condorcet winner, or you should choose. That's the majoritarian argument, right? There is a majority for that alternative, and so we have to choose it. There is no way, that there is no necessity of compromising here, because there is a majority. And now the question is, and that has been discussed, of course, in political philosophy extensively, can a majority, should a majority have the right to appropriate, right, the decision for themselves, right? And there has been this argument made of the tyranny of the majority, right? Suppose that you decide on many issues and there is some bare majority on every issue, then no minority ever gets a voice in the population. And that also seems to be a problem. I just want to hint that these are deep problems, and social choice theory does not offer a solution of that problem, but it makes clear what are the alternatives. Right? It is that what social choice theory can offer. I mean, if you have an intuition, either majoritarian or more compromising solutions, then social choice theory helps you to think all the consequences of your intuitions until the very end. Okay, so that's what I want to continue to do in the next well, a couple of minutes, let's say. I want to show you further results of the sort that we have just seen. So here it is. We have seen this no-show paradox that the Simpson rule has. And then we have seen the theorem by Moulin that actually all Condorcet consistent voting rules somehow suffer from that defect, from this no-show paradox, right? So as soon, this is this theorem part B, as soon as you choose a Condorcet consistent method, which means that you adhere to this majoritarian principle, then you run into troubles with participation, right? Or in other words, you will be able to construct situations where some voters would find it profitable to stay home. That can never happen with a scoring rule, because notice what the scoring rule does is it sums over all scores that voters give to candidates. Now, part A is really mathematically trivial, right? If you use a scoring rule and then voter I asks himself or herself, should I participate in the election where A is chosen? Now, if I give A more points than all the other, I mean, if I submit my preference ranking, then of course all candidates that I find worse than A get less points. So they cannot win. Either A wins, or I can even get some candidate who I prefer because I give him more points, right? So with the scoring rule, this can never happen, that I should rather stay home. So in this respect, scoring rules have a very good property. Namely, they are monotonic in some sense, right? In this sense of participation, right? It is always good to participate in the election. Why? Well, because I give my points to candidates, and that could never harm my candidates. They receive more points if I prefer them, right? So that can never be disadvantages to the candidates that I prefer. But with the Condorcet consistent rule, the question is always, what happens if there is no Condorcet winner? And then something strange happens, and all the paradoxes that occur here in theorem part B are because you have to somehow say what you choose when there is no Condorcet winner. And of course, these examples are all constructed in such a way that if a voter participates, then either there is a Condorcet winner now, or there is no Condorcet winner, and before there was a Condorcet winner. So it's always this switching between the situation where Condorcet winners exist and don't exist that make these paradoxes. Okay, so then the question is, all right, I mean, your majoritarian intuition is good, but it's problematic because there are cases in which no Condorcet winner exists. So can we somehow characterize what the scoring rules can do and what they cannot do? Or in other words, that was the question that Young posed himself. Is there any axiomatic characterization of all scoring methods? And he has one, and this is a beautiful result. That is mathematically very advanced. The proof is many pages and a lot of heavy mathematics. It's a beautiful result, and it's a very simple axiomatic characterization of all scoring methods. Namely, the result of Young is that a voting, why do I write correspondence here? Of course, the reason is that sometimes there are two border winners, right? Simply because it could happen that two candidates receive the same scores, and then they are both winners. So that's why I call this a voting correspondence and not a voting rule, right? Because it could be set valued, right? I mean, sometimes I have a set of candidates who could be the winners because there are ties. And the result is such a correspondence is a scoring method if and only if it satisfies four simple properties. Anonymity, we have seen this condition already, I can permute the voters, so names of voters should not play a role. It's neutral, that means names of candidates should not play a role. If I permute candidates, I just permute the winner in the same way. And then reinforcement and continuity. So let's look at reinforcement and continuity. Continuity is this condition. It is very simple. It says that even if a group of agents would elect candidate B, if another group of agents elects another candidate A, then if I replicate this group here sufficiently many times, then sometimes A, at some point, A must override B. So in other words, suppose there are a group of voters, N1, who would elect candidate A according to the voting rule. There's another group, N2, that would elect a different candidate B. But now suppose I take this group N1 and I replicate this many times. So I take M, for each voter, I imagine there are M voters of the same type in group N, but I do not do the same thing for N2. So N2 stays small, but N1 is replicated M times. And then continuity simply says at some point when M is very large, then the voting rule must choose A. This seems to be a very reasonable axiom. It simply says that it is not possible that one group has such a weight that it can override any opinion of a vast majority, right? That's what this condition says. And then reinforcement is the following axiom. I think here it is. It is a very simple axiom. It says that if two disjoint groups of voters, N1, N2, both select candidate A, and then if I join them, they should still elect candidate A, right? This is related to the no-show thing, right? I mean, this group of voters would elect A, this group of voters would elect A. Now ask yourself, if we merge these voters and let them vote all together, what should be the winner? A, okay? That's reinforcement. Now, again, back to this result, anonymity, neutrality, reinforcement, and continuity, that will give you a scoring rule. Or in other words,
can I ask a question?
Of course, of course.
How is the reinforcement property related to the participation property of Milan?
It is closely related, but it's not exactly the same, right? Participation says, okay, if you wish, you could formulate the following condition that is on the intersection of both conditions. If A is the most preferred candidate of voter I, yeah? And N elect A, and I is the most preferred candidate of, A is also the most preferred candidate of voter I, then if I joins N, A should be again the winner, okay? So participation, this is a bit weaker than participation, yeah? If you restrict this participation condition to the case where A is the top candidate of agent I, then you have a reinforcement condition. But participation is a little bit stronger because it says that no matter what candidate voter I prefers, if A was selected, then with agent I, either A or something better must be elected. Which
so
is,
if a rule satisfies reinforcement, it satisfies participation as well.
Probably. I mean, there is a very close connection. I'm not sure. Perhaps there are results like this. So they are very closely related, but logically they are not the same.
Okay, yeah.
Yes. Yeah. Okay. All right. So actually, Young in the same paper has another result, namely that all scoring voting correspondences satisfy this reinforcement property, and any of these formulations of reinforcement, and that no Condorcet consistent voting rule satisfies reinforcement. Okay, so in other words, Young already observed that these reinforcement conditions, they separate the scoring rules from the Condorcet consistent methods. And the Moulin result is very similar to that. It is not about reinforcement, but about participation. And it shows that the same you can do for participation as well. Okay. Are there questions? Mikhail?
Yeah, thank you. Thank you. That's fine.
Okay. All right. Now, remember that we had one case in which the problems disappear, so to speak. The arrow problem disappears, but also the problem of strategic manipulation disappears. And let me briefly talk about that case of single-peakedness again. Remember that if we give up the universal domain condition, that we should be able to apply our rule under all possible circumstances, no matter what the preferences of the voters are, and we get a good result, if we give up that condition, right, of universal domain, then we get possibility results. And again, let me remind you, this single-peaked case was discovered by Black and Arrow around the same time. I think Black was first. Suppose that there is a linear order over the alternatives. So I can number them, A1, A2, A3, and so on and so on. And suppose that for each voter I, the preference satisfies the following property. The top alternative, called the peak here, and denoted by P of this, is somewhere in this, for instance, for the red voter, it's A1. For the blue voter, it's A4. For the black voter, it's A3. And the single peakedness means that if you take 2 points to the left of the peak, but B is even further away from the peak than A, then A must be strictly preferred. If you take 2 points to the right of the peak, P, and B is even more to the right than A, then A must be preferred. So in this sense, you never have a spike again. You're single peaked. Then you have this nice possibility result, namely, you can simply take the median peak. This is the so-called median voter theorem. Now, there is a beautiful result by Moulin, famous result, that says that the median rule is not the only rule that is strategy proof. Remember, strategy proofness means that no voter has an incentive to misrepresent the preferences, right? So notice, we had some examples before, for instance, with plurality with runoff, where some voter had an incentive to lie about their true preferences, right? To pretend that they would prefer another candidate because that would be advantageous for them. Now, strategy proofness means that nobody should have an incentive to lie about her preferences. And here are all the rules that have this property under the single peakedness property. So suppose that all preferences are single peaked, okay? The median rule chooses the median peak according to this spectrum, and this is strategy proof. Why is this strategy proof? Okay, I think I explained it yesterday already, but I want to explain it again because it's so important. Now, suppose you are you choose the median peak, which means that you choose the point such that half of the people would like to be on this side and half of the people would like to be on this side. Now, how can you change the result? Suppose you're on this side, you want to pull the result in your direction. Can you do that? No, because whatever you report on this side, it will not alter the fact that the majority is already on this side. So how can you change the result? You can only change the result by reporting a peak on the other side. But that risks that the median goes further away from your true peak. So you can change the result under the median rule, but only to your disadvantage, because the alternative chosen will even move further away from your most preferred alternative. So you don't have an incentive to lie about that, or in other words, because Mikhail mentioned this, telling the truth is a weakly dominant strategy. Okay? So please, this is a very important point now, and I want everybody to understand it. The rule works as follows. Each voter submits one peak, one candidate, and the median is chosen. Now, if you're to the right of the median, if you stay to the right of the median does not change, okay? So you can lie without changing the result. That's why it's only a weakly dominant strategy, because sometimes you get simply the same candidate with another strategy. What if you choose the strategy to move to the other side of the median? Well, then it could be that the median moves in that direction. But by assumption, your true preferred candidate is on the other side, and by the single peakedness, right? Single peakedness means the further away, the worse. And therefore, you don't want to do this, because you risk that the candidate moves even further away from your true optimum. So that's why, under the median rule, the weakly dominant strategy in the corresponding voting game is to tell the truth. This is called strategy proofness. And now Moulin, well, it was observed, of course, that the median rule is strategy proof. And the question occurred, are there other strategy proof rules if our preferences are single peak? And the answer is yes. And Moulin identified all of them. And this is a very interesting class. And it's called the phantom voter characterization of strategy proofness. And this I want to give to you. Suppose that all voters have single peak preferences, then every strategy proof, efficient and anonymous voting rule can be obtained as follows. You add to the n votes, you add n-1 fixed votes that you fix once and for all, and then you have n plus n-1 votes, namely the real voters, n, plus the phantom voters, n-1. In total, this is always an odd number, right? Because n plus n-1 is always odd. And now what you do is you choose the median of this union of the true voters with the phantom voters, okay? If you do that, no true voter has an incentive to lie about her preferences. Notice what you could do is you could place the phantoms either on the lowest candidate or on the highest candidate, or you can split that, half of the phantoms to the lower, half of the phantoms to the higher, and then you get the usual median rule, okay? With an odd number of individuals, if you have half of the phantom voters at the lowest possible value, half of the phantoms at the highest possible value, then you're back to the usual median rule. But you can do all sorts of other things. You can place the phantoms uniformly on the spectrum, or you can put 2/3 at the lowest value, 1/3 at the highest value, and you get different voting rules. But the main point is that these exhaust the voting rules that are strategy proof. So this is a very famous result, and it's a very useful result, and it has been discussed extensively in the literature. There are generalizations, of course, of it, and if you're interested, I can give you references. Okay. Let me.
Sorry, can I ask
Yes.
another stupid question?
Of course.
Is it presumed? Am I right that it is presumed that every voter knows those ballots, fictitious ballots?
No,
Or
this is
so
not necessary. This is not necessary.
They only have their own preferences.
They only have their own preferences. And actually, it is even better. You don't even need to assume that they know something about the other's preferences. It's not even necessary. It's not necessary that the single peakness is common knowledge. It is enough that everyone's true preference is single peaked. Okay? And
okay.
yeah. But of course, what they should know, that's actually important. What they should know is where the phantom voters are. They don't need to know where the true voters are, but they know where the phantoms have been placed. That's important.
So they know the distribution of phantom voters.
They know the distribution of phantom voters, but not the distribution of the true voters. Because okay. it's a dominant strategy, it cannot depend on.
Yes, sure. My question was about phantom voters.
Yeah. Yes, they know. Oh, I'm sorry. They know where the phantom voters are. Yes, they should know that. But for any fixed distribution, okay, no, it's even more interesting. They should know that the distribution of phantom voters is fixed. That's enough. They don't need to know where exactly they are, but it is fixed. So the same rule is used no matter if I put my true ballot here or here, the same phantom voter distribution is used. And then it's strategy proof, okay?
Oh yeah, thank you.
Yeah. So in some sense, the answer to your question is no, they don't need to know where the phantom voters are, but they must know that the phantom voter position is fixed. That's the important part. Yeah.
Okay, thanks.
Good. Are there more questions actually? Okay, then. Okay, now we have two options actually for the rest of the course. Well, I would like to discuss a little bit with you again, but then there's also a choice between two things which we could do. Remember yesterday I said that there is an interesting issue of interpersonal comparisons of utility. That if we say that, some persons in the collective that has to make a decision have a strong preference for something, whereas others are almost indifferent. If we decide that we want to use this information, we can also escape some of the impossibilities. And this is under the heading of interpersonal comparisons of utility. This is one thing I can talk about, and it's something that I find very important. But there is also another thing that I would like to talk about, namely electoral campaign. And this is more political economy stuff. And the question is, if we have candidates who can position themselves on a kind of spectrum, what kind of position would they optimally choose? Now, this is a very interesting question that I also want to address. And perhaps you can give me your preference, what I should do first, because now this is really the choice between the two, and I can offer both. Is there any preference among the participants about?
But will you do both of them today? Or?
Well, it depends a bit on how much discussion there will be.
Okay.
And I would like to discuss a little bit with you also. So if I don't see any particular preference now, let me start with the latter subject, right? With electoral campaign. That's how it is called. And this is this slide set. I have prepared something here. Let me go here. There it is. Okay, can you see it? Is it in
everything's fine.
Full screen mode? Okay, very good. So let me do some game theory now. I hope most of you will be familiar with the basic concept of game theory. It is actually here the basic concept of Nash equilibrium. I will not need anything else than Nash equilibrium. And I will explain everything as I go along. So electoral campaign is the question about where do candidates position themselves if the distribution of preferences among the population is known. So again, I will have this example of a one-dimensional political spectrum. I know, and Pavel already hinted at the fact, or I think it was even someone else yesterday, who hinted at the problem that there may be not only one-dimensional political spectrum, but there are also other dimensions. We talked about the Green parties and things like that. But setting this aside for the moment, take the simplest case of a one-dimensional political spectrum. Let's call this P here. And it's simply an interval of real numbers where L is the left boundary and R is the right boundary. And a point on that spectrum simply represents a kind of political ideology, let's say left versus right. It's how much, let's say, redistribution you want, right? The right position is usually identified with a political view that would say there should be no redistribution at all. If you're poor and you don't earn much, it's your fault. Try harder, and then everything will be better. And if you're rich, then you have deserved it. You should not be forced to give anything away from your wealth. That would be the kind of, I mean, it's now a caricature of these positions, but that would be the extreme right position, like a very liberal position, whereas the leftist position would say that no, everything what people earn, they earn only because community makes it possible for them to earn what they earn. So they deserve to give it back to the community. So there should be taxation of high incomes, and it should be given to the poor. That would be the leftist position. And I mean, you could easily say that the amount of redistribution, right, that you would like to see in your society implicitly measures on what position in this spectrum you are. I mean, the most leftist position could be that all incomes should be equal. I mean, post-tax incomes should be equal. And the rightist position would be there should be no taxes at all, right? And you could measure, right, your position in this, and that would be a one-dimensional spectrum. You could measure the point in this continuum. All right. Another example that my colleague likes a lot is how much money in a student council, right? There is some money left. And now the decision is, how do we want to spend the money among us? Should we spend it on beer or buying books for the library, for instance, right? And again, this is a one-dimensional spectrum, right? All the money for beer would be one extreme position. All the money for books would be the other extreme position. And somewhere in between is some money for books, some money for beer. Okay, so that's a very simple example here. But there are many more such examples, I think, that you can construct. All right, then suppose that, and now notice, now we are changing really the perspective. I'm now no longer talking about voters. They are fixed here. I assume that there is, in this spectrum P, there is a distribution of voters, okay? And that is known to everyone. And let's say this is a continuous distribution. A typical voter is called tau, and he sits between, oh, now it's 0, 1. Let's assume this is 0 and this is 1 for simplicity, okay? So the left point is 0, the right point is 1, but that is just a normalization. Now, each voter has single peak preferences. Let's assume that. Has a most preferred position. Let's call this W star tau. This simply means that voter tau prefers to have exactly this value, and the further away from this value, the worse for this vote. So here is, for instance, a voter who would prefer to have lots of money spent on beer. I'm sorry, little money spent on beer, lots of money spent on books. This voter, tau triple prime, has another preference, and so on and so on. Okay, so the voters are located in this continuum, and the question is now, there are candidates running for office. Okay, and now we assume that the candidate with the majority of votes wins, and that each voter, of course, votes for the candidate who is closest to their most preferred position. Okay, it's a very simple model, but it's now what is called a normal form game. There are players, not the voters now. Be careful, right? The voters are mechanically determined, right? They do what is described here. Each voter votes for the candidate who is closest to his preferred position. So there's no issue of strategic behavior on part of the voters. But there is an issue of strategic behavior on the part of the candidates who run for office, right? So the idea is, now there are two candidates, 1 and 2, and they have to position themselves on this spectrum. Like a political party has to take on a position, how much redistribution should be in our party program, okay? And the question is, what happens in equilibrium? That's the interesting question here to ask. Okay, so again, the game is defined as follows. There are two candidates who have to choose a position in this spectrum between L and R, or 0 and 1. The candidate who receives the majority of votes wins. It's a two-candidate election, so there's no problem about majority voting. How do the voters behave? Each voter looks at the two candidates and then determines which is the nearest candidate to my own preferred position. This candidate I give my vote. If there is a tie, I choose with equal probability. The utility of candidates now is very simple and simplistic. But sorry, even in this simple model, something interesting happens. Namely, the utility of a candidate is simply, I want to win. No matter what position I take. So candidates really don't have a position here in truth. They simply want to win the election. Right? So they think about the question, and some political parties do that, right? Remember, they are just opportunistic, right? They think about the question, how can I win the election? What should I say in order to win the election? And not what is my true opinion. So in this simplistic model, they only want to come into office, right? So they want to win the majority instead of being defeated. Of course, if there is a tie, well, you will see in a second that happens with probability 0 anyway. A tie is, of course, worse than winning and better than being defeated. Okay. So let us analyze this. And this is now an interesting thing, and the logic behind this model is very interesting. So that's why I want to present this. So there are two candidates that run for leader of the student council or for election in the national election. Trump versus Biden, why not? I mean, this is really like some real elections here. Now, candidates choose the positions in this spectrum, P1 for candidate 1 and P2 for candidate 2. Now, without loss of generality, assume that P1 is the smaller or equal than P2. This is simply, I'm naming the smaller position that is called candidate 1, that it means. And the interpretation of this P is, as I said, how much money for beer versus books, or how much redistribution, what should be the tax rate on income tax. Which candidate, now let's analyze this. Which candidate does an arbitrary voter tau with preferred position W star tau will vote for? Well, of course, we said already, the candidate who is closest to the preferred position. So suppose that here is P1 and here is P2. What do? You simply take the midpoint between the two positions, and then it's clear everyone, this blue line here, is the midpoint of the two positions. Every voter to the left will vote for candidate 1. Every voter to the right will vote for candidate 2. Okay, because I mean that determines which is the closer candidate. So every voter on this side here will vote for P2. Every voter on this side will vote for candidate 1. That's written here. So if my preferred position is smaller than the midpoint, I will vote for candidate 1. If it is larger than the midpoint, I will vote for candidate 2. And if I'm exactly in the middle, then I will just randomly vote with probability 1/2 for candidate 1, with probability 1/2 for candidate 2. Okay. Now, assume that we know the distribution of voters, and suppose mu is the median voter. Okay? Notice mu, this red dot here, is not the arithmetic mean of the spectrum, right? Because the distribution of voters could be skewed to one side. So it's not necessarily in the midpoint here. It could be anywhere, actually. It depends on the distribution. So if f is the cumulative distribution function of this distribution, then mu is just the point where 1 minus f of p is 0.5. What does that mean? That means half of the mass of the distribution, half of the voters is to the right, half of the voters is to the left. Okay. Now, given that point mu, which voter wins the election? The answer is, it depends where mu is compared to the midpoint of these 2 points. Why? Well, take the midpoint. If now mu is to the right of this midpoint of the 2 positions, which candidate wins the election? Of course, P2. Why? Because all the voters that are to the right of this midpoint vote for P2. We already said this. But if mu is on that point here, these are more than 50%. Okay? So if mu is to the right of this cut point, of the middle point of the two positions, candidate 2 wins the election. All right. In this situation, of course, candidate 1 wins the election. If mu is on the other side of this cut point, then candidate 1 wins the election. And there is a tie between the two positions if mu is exactly on this point. So this is the third case here. If mu is exactly on the midpoint between the two, then there will be a tie between the two candidates. Now, since we know that, we now know how candidates would behave. Now the question is, okay, now the question is, how do the candidates behave? The problem is they have to choose simultaneously a position, right? It's for simplicity, but it's also a very reasonable assumption that both candidates have to choose a position at the same time, or which means that one candidate has to choose the position without knowing what the other candidate has chosen as position, okay? But for both, this is true. So we must find some kind of equilibrium behavior. And what does equilibrium behavior mean? Well, it means that once I see the position of the other candidate, I have no incentive to change my position. So I want to choose exactly the position that I have chosen. And if this is true for both of the candidates, we speak of Nash equilibrium. Nash equilibrium means that given what the other has done, I have chosen a best response to it. And this must be true for every player. So we have two players here, the two candidates. So we should know if the candidates are satisfied with their own decision when they get to know what the other has done. Let's check this. This is called, we have to check the best response correspondences. Now, which means that for every possible position of the other candidate, what would be my optimal behavior? Okay. Now, suppose here, candidate I has chosen some position PI. And let's say mu is to the right of this. This is the first case here. What is then candidate J's best response to it? Well, if J positions too far to the right, then it's clear that candidate I will be closer and will win the election. If J chooses a point to the left of PI, then also PI wins. So where are the positions of PJ such that mu is closer to PJ than to PI? Well, in this region here, okay? So in this blue region, if J puts herself into this blue region, say here or here, then J will win the election given the position of I. Now the same consideration is, and notice this point here is the same distance from mu to Pi, but to the other side, and this is given by 2 mu minus Pi. The same is true if the position is to the right of mu. Again, it's the same blue region where J should position herself. And if I positions him at mu directly, then there is only one way for J to get something, namely also to put herself to mu, and then there will be a tie who wins the election. So graphically, let me show you this graphically. The best response of candidate 2, BR2, to the position P1 is given, this is this blue region if P1 is smaller than mu. This is the blue region here if P1 is larger than mu, and mu if P1 is mu. Graphically, this looks like this. So in other words, my optimal behavior, given what the other does, is in this green region where Pi is fixed and P2 is simply this green region for each fixed Pi, P1, okay? Now, you can do this symmetrically for the other player, and the other player can think about the question, what is my optimal position, P1 now, given a position P2 of the second candidate, and this will be the blue region. Notice that the dotted line do not belong to the blue region and not to the green region, and equilibrium means we now need a point that is simultaneously on the green and in the green and in the blue region. Let's put those regions together. Then you see immediately this upper part here is blue, the lower part is blue, the left part is green, the right part is green, and the only point that belongs to both the green and the blue region is only this point mu. What does that mean? Well, this means that in equilibrium, the two candidates will position themselves at the same point, namely at the point mu. This is a different version of median voter theorem, right? It is also a kind of median voter theorem, but now it's a kind of, it concerns the candidates. When the candidates choose positions in this spectrum, what they will do is they will try to find out where is the median voter, and then they will position both of them at the median point. Is this good news? Is this bad news? Well, the usual interpretation is this is bad news. And why? Because it means you will not see political diversity, right? The politicians will tell the same story because they think by telling this story, they get at least half of the voters. But since both tell the same story, there is no real competition here in politics. There's no struggle, so to speak. What is the right policy? Should we have, what is the right tax system? Should we have more beer or more books, in other words? Right? There is no discussion about that because the two candidates just tell the same story. Oh, let's go for 30% beer, 70% books, because I believe that this is the median voter. So more than half of the people will vote for my position, and I will be the leader of the student council or whatever. So you could, of course, argue, yes, but your model assumed that for the candidates, all what counts is whether they come to office or not. They don't have an own position. They don't have a political vision or so. But yes, that's true. And that would alter the results. But the question is, how big is the role of political vision that politicians really have? And that, of course, is a question I would rather pose to the political science department and not try to answer myself. But I can tell you about German politics that there is a lot of truth in this model when you look at German politics. I mean, German politics, since the time of Angela Merkel, at least, has seen this movement towards the political middle, right? I mean, there is very little discussion and controversial issues are not coming up in some sense. There is a very broad consensus, very little political fight in Germany. You could think that's good, but it has led, I mean, this is the prediction of this model, and this is actually what happened in Germany. traditionally, there were the Social Democrats in Germany who were more to the left for more redistribution, higher tax rates. And there were the conservative, the Christ Democrats in Germany, who were traditionally pro-industry, private enterprises, less taxation, and they have somehow converged. And in the end, if you look at the political measures taken by the Social Democrats in Germany or the conservatives, actually, if you look at the past 2 decades or even further, 3 decades, you will not find much of a difference whether a Social Democrat government was leading the government or the conservative were leading the government. In fact, there was the grand coalition between the Social Democrats and the conservative that led Germany for a long time. So what I want to say is that this little stylized model that I was just showing you, that candidates put themselves in the middle because they think in the middle you can gain the most votes, that is something that you really see in reality. Okay, so that was what I wanted to present you about this electoral campaign. Let me give give some time for questions and discussions. Is there anything you want to ask? Anything you want to comment, add to this?
May I ask you a question? Am I right that this is a quite old model, something like Anthony Downs, like, so it's known for a long time.
Yes. This is Downs' model of.
And this is happening right now, like in Germany and in many other countries.
Yes. Is it? I was just wondering. Is it happening? Is it happening in Russia?
That's a good question.
I mean, I'm thinking of other countries. I mean, Germany is one of the European countries where right extremism is not yet, hopefully not yet an issue. In other countries, what has happened is that the so-called civil parties, let's say, they converge to the middle. But of course, if parties converge to the middle, then those who have a more extreme position, either to the left or to the right, they don't feel represented anymore. And so this convergence to the middle always also has the risk of letting extreme parties living up, right? So, and this actually has happened recently in Germany, where the AfD, which is an extreme right party, has gained in followers, and this is, so to speak, the price of this of this Downsian movement towards the middle, and now people, in particular in the Christ Democratic Party, say that, oh, perhaps we have done too much in moving to the middle and giving up conservative positions. And yeah, I mean, but in Germany, it's a bit different. In Germany, I think it's a prime example for this. In other European countries, it's a little bit more complicated. I would say Italy is some case where the right populists have been even in power for a number of years. So it's an interesting question, but an empirical question, actually. In which countries does the Downs model apply, and if not, why not? Right? So why does the Downs model in some countries work so well and in others not? What is, so to speak, the context for which the Downs model works well? That would be an interesting question, but it's an empirical question, I would say. This is not.
There is another question in chat by Ilya Vaskin.
Oh yes, of course.
he asks you to comment something about Brexit, maybe in the context of the median voter.
Yeah, thank you so much.
Oh yeah, he remembers you too.
Because I asked you yesterday to remind me of Brexit, and now you're reminding me of Brexit. That's very good.
Oh yeah, thank you.
Thank you so much. Yes. Okay, look at Brexit.